In this video, we're going to continue Calculus Topic 6.1 and 6.2 on Riemann sums. This time we're going to be working with what we call a midpoint sum. So we could call this MRAM. So, because it's midpoint rectangular approximation is what that stands for. So this time, instead, we're going to practice drawing our rectangles again. So this is the one for midpoint. So instead of starting at the left or starting at the right, we're going to start in the middle for our height. So in between there, and I'm going to go to the left, to the right, and down. And then again, I'm going to come from the middle between the two. So basically the average of the two, the left, to the right, and down on both sides. Because our goal is to try to make that estimate even better. We're going to come up here. We're going to go to the left, to the right, and down. We'll do one more here. Right from the middle up to the function, to the left, to the right, and down on both sides. So that's what a midpoint sum is. And there is no over or under estimate on a midpoint sum because look, there's some above and some below. So we can't have an over or under estimate on this. So let's try example 5. So in example 5, let's just draw the picture to begin with. So the picture is going to be from the middle to the left and to the right and down on both sides, to the middle, to the left and to the right and down, from the middle to the left and the right and down. And it said it wanted 5. So from the middle up to the function, to the left, to the right and down, from the middle up to the function, to the left, to the right and down. All right. So here's the catch. Before we were doing like 0, 1, 2, 3, 4 in our table. This time we are not doing that in our table. Not 0. What you're doing, x there, and f of x here. So we need to figure out what that value is in the middle. So it'd be 1/2, 1.5, or 3/2. So this would be 4/2, 5/2, 6, 7/2, and then this would be 8, 9/2 in between there. So it's like 1.5, 2.5, 3.5, 4.5. So those are the values we actually want in our table. So I want the value for 1/2, 3/2, 5/2, 7/2, and 9/2. So it's going to get a little bit uglier. Okay. So when I go to square this, okay. And if I wanted to, I could have done this in decimal. I could have done 0.5, 1.5, 2.5, 3.5, and 4.5. That's perfectly okay. So the value that I want here is, so when I square 0.5, I would get 0.25. When I square 1.5, because that's my function, I get 2.25. When I square 2.5, I get 6.25. When I square 3.5, I get 12.25. When I square 4.5, I get 20.25. So I'm going to set up the MRAM the same way I was doing the others. I know I need 5 subintervals, so I am going to set up for 5. And then I use this height, so it would be 0.25. And then the distance in between is technically the distance here, which is still a value of 1 in this case. Delta Math is probably going to shift that up on you a little bit. All right, so my next height is 2.25, and then the distance in between is still 1. My height here is 6.25, and my distance in between is still 1. And then my height is 12.25, and I really shouldn't be doing my distance there. I should be doing my distances from down here. My distance in between is still 1, and then my final height is 20.5. And notice in this one we used all the heights, unlike with MRAM and RRAM where we typically leave one of the heights off. All right. LRAM and RRAM. So when I multiply that out and I add that up, I get 41.25. And if you notice, this is the same function we've done a whole bunch of times. Look at this compared to my RRAM, my LRAM version of it was 55, or sorry, my RRAM version of it was 55, which is a little bit bigger and we said was an overestimate. And then my LRAM was 30, which we said was an underestimate. So we're actually in between the two. So we're between the 30 and the 55, right, that we had before. So this ends up being between 30 and 55, which is good. That's good. We're getting closer to the actual area underneath that curve.